Today we're going to address a common misconception around using function notation in order to solve for x and y. In this problem here, we're given f of 2, meaning that x is 2, and we're trying to solve for the y value. We need to take this x value that we're given, and all we're doing is just plugging it in for x there. As you can see here, I took that x value of 2, I plugged it in, and then I simplified. Remember, since we have these absolute value bars here, absolute value is a grouping symbol, so I'm doing everything inside the absolute value first, taking the absolute value down here, and then multiplying it by 2 at the end. If we look over at this next problem, we're given f of x equals 28. What we're really given here is the y value, and we need to solve for x. So if you notice here I have f of x, I also have f of x here. Well, here I'm told that f of x is 28, so I'm just going to take this 28 and plug it in there so I can solve for x. As you can see in the work, I took 28, substituted that in for my f of x, and then I used my rules that I know about solving absolute value equations to solve for x. Remember, we need to get that absolute value isolated before splitting it into the two equations. Here I have two answers. I have negative 13 fifths and 28, and then I have the point 3 and 28. Take a minute and pause the video to try this problem on your own. If we look at the answers, we get f of negative 1 gives us 7, so the point is negative 1, 7, and f of x equaling 13 gives us either the point negative 5 halves and 13 or 7 halves and 13.